Okay, now we talk about arrays. Arrays are homogeneous collections of values, and there's two ways of doing it. There's static allocation and dynamic allocation. In this class, we will only cover static allocation because that's what CS1010 covers, and dynamics a little bit gross. All right, so and it has to do with memory allocation, which I don't really want to deal with, right, at this point. So anyway, arrays are very similar to your lists you learn in Python. Python lists are a little bit more liberal, but for arrays, you need to declare the type, right, of the array, and elements of the same size, the same type, okay? And typically in what you call static allocation, the size of the array is fixed at declaration, and arrays are mutable, like lists, okay? So a simple example is that you can declare an int array of 4 integers, okay, and you can put 2, 7, and 8. So it turns out that this will map to 0, 1, and 2, just like in the Python list, and then the 3 is actually indeterminate, and the 4 will be out of bounds, right? Okay, so you can declare the array as follows. You have the type of the array, the name, and how big the array you want to be. Okay, so if you do list of rails 10 float, you have 10 different variables. And essentially what you're doing in declaration is you're actually, allocating memory. You're saying that I need to set aside so much memory for my array. All right, let's quickly see how we can initialize arrays. So one simple way of doing it is that you initialize the size and you set some values. All right, so 3 elements to 3, okay? If you're too lazy to do that, you can just set this to null, and then you just put some numbers here. Automatically, you set B to 3 elements because you only have 3. Now, on the other hand, you can set a big array of 5, and you have initialized the first 3. So last 2 numbers are now indeterminate, right? And if you do this whereby the size is smaller than the elements here, you will throw away the last one, okay? But you have just 2 element array. Now, you can't do this initialization using this method. It means you can't do F5 because of this thing. It's way too late. But what you can do is you can do F0 equals 8, F1 equals 23, and so forth. Okay, but this particular declaration is not possible or not allowed. All right, so let's take a look. Essentially, arrays are pointers, right? So you can do int A5, okay? You print A, you have this address, right? Because it's the address of the A variable. And if you check the addresses of the various array elements, you realize that they are just incrementing by 4 because an integer takes up 4 bytes. Okay, so you can actually do something like this, right? So you can pass array into a function, a certain size, okay, and then you basically for I the size less than this and so forth, okay, you can sum up the array elements and you can return the total. Okay, so the declaration is that as follows. You have the int, which is the type of the array, and then just declare as an array, okay, like this. Okay, and then typically you need to give a size because otherwise inside the function you don't know how to actually declare this thing. Okay, we didn't talk prototypes, but typically what you need to do is that you may have to declare the format of a certain function, and this is what I call prototype. Prototype doesn't require you to name the variables because it's not actually used. Okay, and when you call the function, right, you basically pass in the array, okay, and a number which is size, and it's done. Okay, so the size of an array is actually 7. It's the number of elements times 4. Okay. So what else can you do? You can also pass pointers, right? Okay, and do things like this, but don't do this, right? Do the normal array way, and it's easier. Okay. Now, so it turns out the array variable is like a pointer because it is a pointer, and there is no way you can actually protect against the outrange. So you check manually, and sometimes the compilers can help you check. For example, if you do list 7, okay, equals to this thing, then you do list 9, then essentially the compiler can check that you have warning, you're out of range. Okay. Okay, and some things are legal, sometimes illegal. So we do this thing, okay. You can do like define n is 10, okay, and then you basically create an array of 10 variables, 10 elements, and then you set some of them. Okay, destination is 10. Okay, for int you can just copy. Okay, now if you do the same thing and you do destination equals to source, this is illegal because you can't actually assign the arrays this way. Okay, you need to actually copy element by element. Okay, so printing arrays, there's no easy way of doing it. There's no printf array. You need to iterate through each element. Okay, and what you can do is write a simple helper function. Right, and then you can also have multiple dimensional arrays. So basically, instead of declaring 1 dimension, you can declare more dimensions. You can declare 3 dimensions. Okay, and you just call it as per normal. Okay, let's take a look. So for example, if you have a nested 2D array, you can actually have an inside array, and then all together outside is another 3D array. So it's 5 for inside and 3 for outside. Okay, or you can just set inside dimension and outside let the compiler decide for you. Okay, and you can also have implicit 0 values by just setting some. Okay, there's also this thing called arrow notation, which is a shortcut notation for array of structures. Okay, so essentially, if you actually refer to cooldown using a pointer, okay, pointer open parentheses and then dot h, right? Or you can just do the pointer, this arrow notation and hr, and you get the same thing.